All right, everyone, welcome back. Today we're going to talk about chemical reactions, activation energy, and enzymes. I apologize, but our pen still isn't working, so I can't write on the board or on your screen. I'm going to try to get that going as soon as possible. Okay, so let's get started. Like I said, we're going to be talking about enzymes or koso in chemical reactions, kagaku hanno. First, time for potatoes. I just want to remind you of the potato lab that we did. We had potatoes we had 3 test tubes full of hydrogen peroxide. That's H2O2. Now, when H2O2 is exposed to light, a chemical reaction happens and it breaks the H2O2 bonds into H2O, which is water, and oxygen. Now, that chemical reaction happens very slowly. So, once we put in the potato, a slice of potato, we observed that it went very quickly. We started seeing lots of bubbles everywhere. It looked like foam, and oxygen was being released very quickly. Then we put a slice of potato that was boiled and noticed that there was no change whatsoever. Nothing happened. The final potato that we put in there was frozen, and bubbles were made, but it was slower. And at the end, we realized that the reason why this was happening was because potatoes have an enzyme called catalase that increases the rate. It makes the reaction quicker. So enzymes, at a very basic level, they make reactions, chemical reactions, happen faster. They are catalyst. A catalyst is something that makes a chemical reaction go faster. When the potatoes were boiled, that enzyme was taken out of the potato and left in the water. It was all broken up. And once the potato was put in the H2O2, nothing happened. And then we saw that with the temperature, the lower the temperature, the slower the chemical reaction. Okay, so that was just a little reminder of what we did. So basically, life depends on chemical reactions. We need these chemical reactions in our cells. We have thousands of chemical reactions as part of our life process. That's the only way we can stay alive. These reactions are important to the growth, the development, and the survival of a cell. Without that, a cell will not grow, it will not develop, and it will not live very long. The reactions of a cell are involved in building or making of molecules and of the breaking down of molecules. Okay, so either making or breaking down or dividing molecules. The role of enzymes is to greatly enhance the speed of the reaction, so make the speed of the reaction faster. Okay, chemical reactions, or a chemical reaction, is a process that changes one set of molecules into a new set of substances or things. For example, 2 molecules of hydrogen and a molecule of oxygen, when put together, are water. Water is a new substance. Hydrogen and oxygen are very different than water. Okay, their shape is different, their properties are different. So when these molecules have a chemical reaction and bond, they form a new substance called water. A chemical reaction occurs when chemical bonds between atoms are broken or formed, which is what we talked about, to make new things. So the reactants are the things that we put inside the chemical reaction. So for example, hydrogen plus oxygen, those would be the reactants. Those would be the reactants over here. Then the product is what comes out of the chemical reaction. So if the reactants are hydrogen and oxygen, then we add energy, we get the product, which is H2O, water. So here are some more examples. Here we have CO2 plus H2O. These are the reactants. And then the product, right here we have energy. The product is H2CO3, okay? Over here we have 2H2O, 2, I'm sorry, 2H2O2, energy. So these are two molecules of hydrogen peroxide. Some energy, you get 2 molecules of water as a product, and a molecule of O2. Now, notice here we are combining, so we're putting two things together to get a product, and here we're taking something and we're breaking it apart, okay? Okay, so let's talk about energy in these chemical reactions, okay? So whenever chemical bonds form or they're broken, energy will either be released, so release, let go, or absorbed, which means to go in or take in. The forming and breaking of bonds involves changes in energy. So to break a bond, break a connection, or to make a connection, you need energy. So some chemical reactions take in energy, or absorb energy, that's called endothermic. Now think about endothermic is similar to endocytosis. Endo means to take in. Other chemical reactions release energy, let energy go out, and that's called exothermic. So think about exocytosis, okay? So exo goes out, endo goes in. Some chemical reactions let energy out, and some chemical reactions let energy in. So it doesn't matter if it's endo or exocytosis, or exo or endothermic. To start this reaction, you need to put energy into the system. You need to start it off with energy. In order for the reaction's products to form, existing chemical bonds in the reactants must first be broken. This will require energy. Okay, so for example, to make H2O, we needed 2 hydrogen, 1 oxygen. We need to break the bonds of the hydrogen and connect it with the bonds of the oxygen. This needs energy. This requires energy, okay? Now that energy is called the activation energy. That's the energy you need to start a chemical reaction. So it says right here, the energy needed by the reactants in order to start a reaction. It's the first amount of energy you need to start a reaction. It's the energy required to break the bonds in the reactant molecules. So let's look quickly at an energy absorbing reaction and what happens there. So the reactants have less energy than the product. Okay, so we see here that the reactants energy is pretty low. You have to put in all this energy. In our H2O2 example, that was light energy, right? And then you get the product, which the energy is much higher, and our product in our H2O2 experiment was H2O, water, and oxygen. The bonds of the reactant molecules will have to be broken. New bonds will be formed during the formation of the products, okay? So the activation energy is the amount of energy that the reactants will have to take in to absorb in order to break the bonds holding the atoms together. Okay? So this is all the energy that our reaction is going to need to break the bonds of our H2 to make, or in our H2O2 to be able to make H2O2. Or to make H2O NO. All right, here's an example of an endothermic reaction. Okay, photosynthesis. This is the process that that takes in that plants use to turn light into energy. So we start here with CO2 and H2O. We have to put in all this energy in the form of light, and the product is glucose, which is a type of sugar. Okay, so as you can see here, we have H2O and CO2, and the energy here is much lower than the energy in glucose. Okay, the energy that's taken in, that's absorbed by the reactant, is stored in the bonds forming the glucose molecules. So, like I said in class before, if you have water and you drink water, or you have glucose, you're going to have more energy from glucose. That's why people and animals eat plants. They eat to get the energy that's stored in those molecules. Now, an energy releasing reaction is the opposite, okay? The reactants have more energy than the product because you have to put in all this energy here, and then it releases a bunch of energy to get the product, okay? So that's an exothermic. An energy investment will still be required in order to break the bonds of the reactant, okay? You're still going to need that. So in this case, the activation energy is the amount of energy that must be absorbed by the reactants in order to break the bonds holding the atoms together, just like before. All right, so let's look at cellular respiration. Okay, this is what happens within cells. So they'll have glucose and O2. They'll have energy, and then it will release all that. The product of that reaction will be CO2 and H2O. So the bonds of the glucose and the O2 will be broken and will be released as CO2 and H2O. Notice that the energy is much lower in the product than where it started. Okay? So the activation energy is usually in the form of heat. The bonds of the reactant break. The bonds of the reactants break only when the molecules have absorbed enough energy to become unstable. So the connection between the molecules will only break when there's enough energy to make it unstable. Okay? Activation energy is the amount of energy needed to push the reactants over an energy barrier, or kind of like a hill, so that the downhill part of the reaction can begin. And that's where we're going to stop for part 1.